Okay, so it's Luca here. I'm Luca Penasa. I work for the Italian Institute the National Italian Institute for Astrophysics, and we will be working together with Riccardo. We will be working with you to give a little bit of an introduction of QGIS. This is really useful for anyone that might have never used QGIS. But if you already did, you can also find something you might not know. And well, let's start. There is a little bit of an introduction here. The first point is that if you haven't downloaded the dataset, use this time while we do the presentation to download the dataset you are going to use. Is a tile of the Copernicus crater, a little piece of the moon surface, and Riccardo will say something more on the target later probably, but anyway, just be sure to have the data. So we are going to use our software to perform the mapping, which is called a GIS, a Geographic Information System. And the point is that in traditional cartography, so many years ago, people used it to perform interpretation actually by hand, not using computers. So when people started to move into interpretation, geological interpretation using computers, so specific software were developed. And the only point I want to make here is that whenever you create a geological map, you interact with this software to create a well-established data set that is then only later used to create a paper version of your map, for example, if you really want to print it out, or to create a PDF version of your map. The interesting point is that now, using that data set, you can pass it around, give it to another scientist, and they might be want to improve the data set, improve your geological map, your geological interpretation, or maybe they will be using it again in a GIS to perform some different analysis. So, for example, to intersect the geological units, the geological information with any other kind of information like a path of a rover over the surface, so to get information of the different units that the rover will intersect during the path he will be performing. So that's the only point. The reason why you might be doing a geological map, a mapping project of a planetary body, the reasons might be different. You might be, I will start from this item on the right, because I believe most of the people will be working in this way. You might be interested into it because you have a specific scientific question, so you want to find an answer to a scientific research question, or you might be part of a mission, so that's the point in the center of the table. You might be part of a mission, and of course, when a new mission arrives to a planetary body, they will perform the higher resolution as possible mapping. Possibly they do global mapping if it's an orbiting mission. And of course, there will be an effort that will be organized at the level of the mission to create new geological maps, in general, new maps for that planetary body. And there is probably a third kind of mapping programs that are more structured, like the one that is kept alive by USGS, when USGS makes an effort to actually keep produce updated maps of planetary bodies of interest. I just keep a couple of slides. Those are just examples. You can then have a look at them later. So this is the case of a very systematic mapping where one tries to cover the entire body. Of course, with the resolution we have with contemporary mission, you will need to probably split up the work in many different map sheets. And this is another example where you just have one single spot that maybe the scientist found really interesting for some reason, or because he was approaching it from a scientific point of view, and they just created different single sheet maps. Okay, so GIS, Geographical Information Systems, they are software. Some of them do have, let's say, a graphical interface you can interact with. We will be using QGIS for the exercise, but there are many others. If you work in university, for example, you may have found that ArcGIS is quite used a lot, but there are others that are open source, and you can probably find them online, download them, try them out. We will be using QGIS because probably is the more easy to use. It's well supported on any platform. But well, if you are curious, you can go there and try to find out about many others and also try them out. The only point I want to make at this moment is that if you never try to use a GIS, there is this point that maybe requires you to understand a little bit how to be able to actually use it. And the point is that there are two different kinds of data that you can use in this software. So typically, I don't know if you have experience in any other software, complex software, like, I don't know, if you do CAD modeling. So typically you use mostly only one type of data set, but GIS were basically created to support both. And the first type is vector data, and the second one is raster data. We will start with raster data just for you to have an understanding what we are talking about. So raster data are basically images, and exactly like any image, you have the smallest, let's say, element in the picture, that is the pixel, and within that pixel is stored the information, like, for example, the RGB colors information if you have a regular picture. But most commonly in planetary sciences, you use raster to have just a single value. You can have raster collecting just one single band. Most of the time, when you have multi-filter images, you usually organize that raster in multi-band rasters. And the only point I want to make is basically a matrix. So if you have a look here at right, where there is this topography title, each image is basically a raster where within each pixel you can collect information, numeric information. You can collect, in this case, just integers, for example, or any other other kind of numeric data. So you can use them also to store the information about the topography of a certain place, or you can use it, like in the center image, to store the information about a classification. So this was, for example, an example in which they did a classification starting from, I don't know, multispectral information, and they classified the different land use. That's not a planetary case, of course, Earth-based one, but you can store using different integers. You can store the information about different classes. And here you see some examples. So you can use raster to store altimetry, or just plain images, or classification results, or anything you can actually quantify, and anything that is actually a value that changes over a topographic region. So vector data are quite different. The very basic types of vector data that we will use are points vector data, lines vector data, and polygons vector data. So let's give an example just to be clear. Here is a little scheme I took from some books. Point data are used to map features that can be approximated by just a point, right? Any features that you might want to map do have an area, but depending on the scale you are performing, you map at some features will be best approximated by just a point. So in this case, you see they approximated the well's position around this lake by just using points. So in that case, you will use a vector layer with points type. But of course, you can have lines and polygons. The idea is the same. You will use a line to approximate anything that is line-like. So like a river, at a given scale, you won't see the actual width of the river. You can actually trace the river like it was just a line. You do the same, for example, if you consider a geologic context, you do the same for fractures, which you might encounter, you might find like faults or anything like that they do have a width, but at the scale you are considering most of the time, you just consider them as a single line. And the last type, that is one we will be actually generating for the geologic map, is the polygon type that you might use to represent anything that is an aerial distribution, and for which you can define with a line, again, the boundary. The interesting point is that for each feature, so if you consider a point input, for each point you can store any kind of information. If you have lines, for each line you can store additional information, and for each polygon you can store additional information. For each layer you can have any number of points, any number of lines, or any number of polygons. And for each layer you have a table where you can store additional information. You see an example of a geologic map where each unit has stored the unit name in this table, and is connected in this case with each polygon representing the unit. But I mean, this is just to give you some keywords so you can follow along later when we will be performing the mapping. So the idea we will be trying to follow is that whenever we perform a mapping, we will start with just a line layer that will be subdividing the region we will be mapping in different areas. This line layer, together with an additional point layer, it will be enough to generate polygons where each polygon will be labeled with the information containing in the point layer. It will be clear later. We will be exercise these several times before you actually end up doing your map. Here is a real example where we started drawing the contacts between different geological units. So each contact is actually a line. You create several of them. You close them one on top of each other. You don't need to be really precise, actually. You will experiment it later with QGIS. Then we provide a label for each of the unit we identified. So we have 3 different labels, one for each unit. And then basically we will use the mappy plugin we created to generate the final polygonal layer. Nice point is that you can go back anytime. You can go back to improve the contacts. You can change the point layer to alter, to change the final result, that is the polygonal layer. So we will start right away to have an overview of the main interface of QGIS. Then we will have a look at the QGIS project Riccardo created for us. We will have a look at how it is structured in terms of folders. So if you someone gives you a project, how it looks like. And I want you to be able to move around, to zoom in, zoom out, and perform the very basic operation with QGIS. We will see how to install plugins because that is quite important. Then Riccardo will take over, will show more in detail some of the things you can do within QGIS. Then again, we will see something more advanced. I will be back probably in this, and we will see something more advanced in QGIS. So as I said, we will start with the main interface of QGIS.
Luca, you're muted.
Sorry, Riccardo, I just moved the Zoom toolbar just to, and I press mute. Anyway, this is a slide you can find if you go and download the PDF of this slide, you can have it as a reference. It's just some terminology. We're going to see it in the actual QGIS. I will open it up in a moment. And I believe it's basically everything. I'm leaving here also some links that might be useful for you. And Riccardo, if it's okay for you, we can start actually opening up QGIS.
Yeah, sure.
Before doing that, I want to go here because I downloaded already the dataset you're going to use, you're going to need. Just one word, it's not like you really need to follow along everything. It's better if you try to do that, but as it is recorded, you can always take your time later to have a look at the recording and try to perform everything. We will do the same things again and again and again. I mean, I will try to perform everything at least twice. And also Riccardo will show basically more or less the same things later again. So don't be mad at you if you missed anything. We can go back on that. And if you really need to ask questions, I believe you should be able to do that in the chat. So this is the dataset. If I open it up, you see it's a folder. I will uncompress it. It is a zip file. I will uncompress it here. Of course, this might be done in a different way on your system. If you are on Windows or Mac, it might be done differently. Anyway, you see the project that Riccardo put together is just a folder. And within that folder, as we said, we have two different subfolders. One is raster and one is vector. This, how Riccardo wanted to organize the data, is not mandatory that if you ever do your own project, it's not mandatory that you create a project like so, but it helps you keeping everything clean. And you see we have raster data. As we say, raster uses to store information about the DEM, so the topography, the elevation of the region. We have some Clementine data, and here a mosaic that can be used as a base map. And we have a second folder, which is the one containing vector information. And for this, you will only find the Copernicus map geo package. And the really important thing here is that this file, with the extension QGZ, is the actual project of QGIS. So I will open up QGIS.
One thing I want to point out before you go ahead, this folder structure is made like this for a reason. So if you're working on a project, and you want then to move the project around your computer on an external drive, or you want to pass a project to a different person, this is a good way to keep all the data inside a folder structure. So if you want, for example, to, as we did, to move around or to spread your project like this Moon final release 2024, we have inside the folders raster and vector and project file. Of course, they can be saved anywhere into your computer, but if you want to give a project to somebody or to cooperate with somebody, you just cannot share only the Moon GMAP QGZ project, but you also have to share the raster and the vector folders. And if they stay contained within a same, let's say, parent folder, everything should remain consistent throughout every type of moving or sharing or rearranging. of course, anyone can have different way of organizing the work, but this is a good way to share, move around stuff.
Yeah, indeed, the issue is that you see here the project file is a very small file, it's just 12 kilobytes. And of course, it's not possible that it contains any very big information, any large file. Indeed, the large files are stored outside the project. You see, in separated folders. So if I give only this file to, I don't know, to Riccardo, he will try to open it up. But QGIS will complain that he cannot find the large data.
Basically, that file is just pointing to folders in your computer.
Yeah, we can show you. Let's say I open this project. I will just drag and drop it. Let's open this project. You can. There is a raised and let's open the project, and you see everything gets loaded correctly. So we can see the image. We have some warnings. Nothing you should be worried about, but. That's great. Okay, so the project opened correctly. Let's see what happens if I, for example, I will close this project. So I'm again with this window, and I rename the paths, so the folders, to vectors and layers. When I open the project, you see QGIS will tell me, look, I'm looking for something that is called dot raster, Clementine, etc., etc. I'm looking for also those layers, and I cannot find them. So you see there is a auto find button here you can use. Well, it's not really important at this point. The important point is that whenever you move around your project, it's not enough that you provide the QGIS file. You have to move around all the files the other person is supposed to have available.
And within the same folder tree, so...
Yeah, exactly. So yeah. QGIS store the path information of the files should be loaded in the project files, but it must be able to find them. So let's close again this project. One thing I want to do just before starting is because some of you might already use QGIS in their everyday life. So if you open it, QGIS, you might end up with something really different from what you see here. So just to be in the same condition, what I'm gonna do, and you can do also if it's not the first time you use QGIS and you want to be, let's say, to have a clean interface matching more or less exactly what you're gonna have a look at. You can create a new profile here. So you go under settings, you have the menu on top. Under user profiles, you see there is now we are in the default profile. We can create a new profile. So again, under settings, user profiles. I mean, this is not really needed if it's the first time you open QGIS. But if you do any, I mean, if you already use QGIS, you might want to do it. I call it.
And that's because QGIS can be customized very deeply in terms of interface and plugin that you use. And maybe you want to use QGIS enriched with some functions for specific projects, and then maybe to start fresh to do some training, like in this case. And this is a good way to create profiles that can be more or less rich of functions depending on your needs. But this is,
So you see now we are in a different profile, Winter School 2024. Let's say it here. Under setting user profile, you see now is selected the Winter School 2024 profile, and you see the interface is slightly different. We are missing some items here. We are missing also some items here because this is the default condition that QGIS comes in. So I will close the other profile. So we are not going to use it and just keep it open this one. Okay, so I would like to start from some naming. I already told you that is this part on top is the toolbar where you have all the different let's say you have access to the, let's say, text version of the buttons that you can find here, but you often also have much more tools. So you can use the project, for example, menu item to open the project. If I press open, we can go and try to find the project here. Here it is, we can open it. It will complain, will give some warnings, nothing you should be worried in this moment about. But here is the dataset that Riccardo prepared. I would like you to open it up so you have something, to look at. And just before to move on the, let's say, the navigation of the map and zoom in, zoom out, that is quite easy with a mouse. So be sure to have a mouse around. Those are called toolbars. Riccardo, could you make a little rectangle just to help people to see? Thank you, Riccardo. So the toolbars collect in a, let's say, easy way many different tools, and you have many different toolbars, and in a moment I'll show you how to open and close them, because we will need additional toolbars that are not included in the default, let's say, installation, or at least when you first start QGIS. Eric? Is everything
sorry,
okay?
I was about
Okay.
to say something, but you anticipate.
Oh, okay. And what we also have here are panels that you can actually move around. You can organize the screen as you like. So in the default view, you see here we have the browser panel that gives you access to the local, let's say, local data, and also remote data that you can access. This is another panel that is called layers, that is probably the most important for what we're going to do, because you will need to organize your, in this case this was already done by Riccardo, but you will use it quite often. And that's basically everything. The last part is those are the panels, and on top you have the menu. Those are the toolbars, the toolbars, and on top you have the menu. Typically, keep in mind that everything that is in a toolbar, you can also find it if you go within the menu. The only issue is that in the menu you have much more stuff, and sometimes it might be difficult to navigate it and find everything. That's great. And the last part is the bottom one. Not that we are going to use it too much, but I just want to show you that there is a quick access button here in the bottom right of the screen that gives you information on the current reference system that is used. If you click on that, you will find out what reference system is used for the project, which means basically the one you are using when you visualize your data. There is nothing we actually need to do. The last thing I want to say is how we open or close panels or toolbars. So the menu is just one, you can create more than one, but you can open and close toolbars and panels. So for example, if I go over an empty spot of the toolbar and I do a right click with my mouse, you see you have this dialog which lists all the no panels and toolbars, and you can use it to activate or deactivate. So for example, here we have a browser panel that is activated, that is this one. If I right click again, we have the layers panels, that is this one, right? In terms of toolbars, we have many already activated, like the attributes toolbar, data source manager toolbar, etc., etc. So you can try to activate or deactivate stuff. So for example, I deactivate the browser panel, like so. I activate it back again, so we have again the browser panel. The same for the toolbars. So for example, we can activate the advanced digitizing toolbar. We are going to use it anyway later. So you see it open up a new toolbar. You can move actually them around. So if you want to customize your interface, you can move them where you want. I just keep it here because it's kind of the default order that come out. So it should match easily what you have on your side. I believe, Riccardo, it's almost everything.
Yeah, maybe we want to show the processing toolbars.
The panel, yeah. Another panel we might be using is the processing toolbox panel, this one. You might want to already enable it. Processing toolbox panel. Here it is.
Yeah, there are many ways to do that. One is right click and go there. Another one is to click into this gear icon.
Yeah.
Or another way is to go onto this processing menu here at the top.
You see,
so there are multiple ways to reach the same result.
Typically, the same action, the same tool that is under the menu. So, like in this case, you can access it. Not all of them, but most of them. Also with key combination like Ctrl+Alt. If I press Ctrl+Alt, it should open it up. Probably not because I'm sharing stuff. Sorry, guys. But anyway, you should be able to do that. You can click on it, so opening the processing toolbox, like so. If you want to close it, you can close it also this way, or you can open it up here with the toolbox button in the toolbar. Okay, should be almost everything about the interface.
Yeah, no, I think the interface, and sometimes you can lose your data around the main canvas, and there's you can show a way how to zoom to the layers, just in case.
Yeah. Okay, so now if you open up the project, you should have something like this, where you have this base map, let's say, and all the data sets that have been loaded, that were prepared by Riccardo within the project and saved as a project, are listed here. So you see, if we collapse all of them, we see those 4 groups. You see there is a little clip here with a couple of sheets of papers. That means it's a group of different data sets. So it's a group of linear features dataset, of a point, of another line feature. You see there is a little line here, it means it's a line layer. If I stop with my mouse on top of it, I see some information. It tells me that is a line string layer. For example, this one is a point one. If I stop, it says it's a point layer. And again, for example, we have another group that is called visible because it provides raster data in the visible. And if I hover on top, I'm getting some information where the data is actually located. The same for the claimant time. If I hover on top, I'm given some information. So each group can be activated or deactivated. So for example, if I remove the Lola dataset, I can activate and deactivate it. But you see this is a group, so it's actually deactivating all the layers that are stored within that group. So for example, I can show you the other layers. The thing here is that it works kind of like any, say, image processing software. If you ever use Photoshop or something like that, you have layers, you can group them, so to have quicker access to activate and deactivate them. Each layer is drawn following the same order. It is in this panel here. So if I move this on top, it will be rendered before all the other groups and so on. Same within the same group. So if I enable this layer here with the color-coded DTM, I can move it below, and so I just have the hill shade representation. Here is the slope. I can move it in a different order, and of course I will be seeing only the one on top.
Of course, one can adjust the transparency so you can see multiple layers one on top of the other.
Yeah, we'll see it in a moment. I just wanted to, two words, I'm pretty sure you already figured it out, but to move around on the map, you have to use the left click of your mouse, left button of your mouse, so you can click and then move around, okay? To zoom in and out, you can use the wheel of your mouse, so that's why it's useful to have a wheel, because it might be difficult to do that on the laptop keyboard. But anyway, there are buttons here you can use if you don't have it, so you can zoom in a specific location. It's located in this toolbar, which is called the Map Navigation toolbar, and like any software, basically, you have zoom in, zoom out, zoom to everything, basically to zoom full, and etc. etc. You have other tools. I believe Riccardo will show you later the bookmarking tool, but anyway. That's all for the interaction. You don't need to know much more about this. I would like you to try it out, and if you have issues, report back. I will basically show it quickly again. Okay, if it's okay for Riccardo. Is there anything else that comes to your mind?
No, if it comes to my mind, I will say it. But
okay,
no,
I want I want just to very briefly go over everything. So project, to open the project, we can do like so, or you can just drag and drop the project file. I will open the project, so I start again with a clean data set. The layers panel is probably the most important in this moment. You can enable, disable panels by right-click in any empty space of the toolbar, and you see the list of available panels and toolbars. For example, one panel that might be useful is the processing toolbox panel we will be using later. This collects basically any kind of algorithm that can be used to process GIS data. And you can enable, disable groups like so, or enable or disable single layers, right? Riccardo was mentioning there is an opacity slider. Riccardo added it. You won't have it by default, but Riccardo added it. He will probably show you how to do that. And you can increase or decrease the transparency of the layers. And of course, like in Photoshop, for example, you will have the lowermost layer showing up, the lower layer showing up, depending on the transparency. So it might be useful if you need to go back and forth between two representations. You want to keep a little bit of the top layer information on top of the base map when you perform your mapping. So you can group them as you like. So this is the Clementine dataset, for example. There is only one raster with 3 bands used to produce the colors. In the visible, this is the WAC camera. And of course, we have the vector layer that we'll be using to perform the map. So very quickly, I will show you how you will be working with the vector layer to create your map. And this is something that Riccardo will show you again in a moment. Do we have time, or do you want Riccardo to start? I'm not tracking too much well the time.
No. You can go ahead. I think.
Okay, so if there is
Yes.
just one thing you have to understand now is how you will be performing the mapping. So we will repeat it at least twice, one by me and one Riccardo later. And when we do so, we might introduce you with some more advanced stuff. But if there is only one concept you have to bring home, that's the one we are going to see now. So to work to perform geological mapping, you of course will need some kind of base map. It is the Clementine data. I'm not really interested in this one. Let's say we stay for the moment with just the DM, the hillshade, just because it provides a clean overview of different units. We are not actually going into the interpretation now, so we do very simple stuff for you just to understand, and then when you will be performing the mapping, you will get better scientific insights on what you are actually doing. The way we will be operating is that we will need to edit only two layers. One, the ones that are called source, so the source contacts and the source indicators. And I will give you a demonstration how it works. To be able to edit any vector layer, you first have to select the layer you want to edit, like in this case the source contacts. At that point, you need to enable the layer for the editing, because by default QGIS will not allow you to make changes to your data. So you can either right click. By right clicking on the layer, you open up this dialog where you can find toggle editing. You can use that to enable the layer for editing. As we say, same stuff, you can find it in the toolbar, which is called the digitizing toolbar. And you see there is only one button that you can press, and it's the toggle editing. But it's basically doing the same. So if I right click on source contacts, I enable the editing. Now I can actually edit my map. I will give a very quick example how to add lines to these source contacts layers. To do so, you will need to press the add line feature that is located again in the same toolbar. So the digitizing toolbar is then, let's say, the next activated button at right of the toggle editing. So add line feature. At that point, you are in a future adding mode, let's say, and you see the pointer of your mouse changed when you move on top of the canvas, and you can actually start to do mapping by left clicking with the mouse. So it's not very visible, so let me draw some of them. I click. What you are doing basically is you are fixing points along a polyline. And one important thing is that you need to cross each line. You will see why it's important. And just by pressing OK, you create a new feature like so. So in this way, features are not very well visible. I show you quickly how to change the display options for that layer. If you right click again on top of the layer, you go over properties, you have this dialog where you can edit several, you have general information where the data comes from, but the most important one is the symbology one, and you will see you can create very complex legends for your data set. For the moment, I will just change the color to, let's say, a nice black one, and I will change the width to something more visible for you. And here we are. So we created our first line. Let's say this is the exterior boundary, let's say, of the crater. It's not really important to use now adequate scientific terminology. I just want you to focus on using QGIS and on how to create new features and edit the layers. So let's say I will trace an additional line here. That is a new contact. You see that whenever you finish creating a new line, you need to right click. So I'm performing it again. So you start by left click, left, 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 left. When I'm happy with it, I just make sure I will go over the starting point of the line, and at that point I will do the last one of the left clicks. When I'm happy with the geometry, I can at this point do a right click that will close the line for me. We close not really close the line, but we stop the editing of that line. You will have this dialog where we already prepared a field that is, for example, certainty. You could add more if you want, but for now it will be enough. So, for example, you can specify something. For example, how much you are certain about that contact. So you might be certain, you might be uncertain, and so on. So, for example, I can do like so. So I created all those different geometries. Now, you need to save. You just remember that when you save the project, like so, the project will be saved, but it's not obvious that all data sources you were editing have been saved. To do so, there is a dedicated button here, which is Save Layer Edits, which is in the digitizing toolbar. So the same place where you enable for editing. And just at right of that pencil, you have Save Layer Edits. And once in a while, be sure to press Save. Now, let's say I'm happy with it. I can disable editing of this layer. So the next point I want to show you is that to generate this map, the polygonal version of this map, we are going to use a plugin, and you might have already installed, but if not, just follow me. We are going to install it. Under plugins, so in the top menu, there is the plugins item. You go over in manage and install plugins. You will sync with the remote database, and you can find many plugins here. We are going to install, we are going to enable a couple of settings here. So let's do it again, just to be clear. Under plugins, manage and install plugins. We move under settings here, and you see you have a couple of options like show experimental plugins. We enable that one, and we then reload the repository with this button here. So again, under settings, we enable the option show also experimental plugins, and we reload the repository with this button, and that's all. At this point, under all, you see I can now find the mapping plugin, which is marked as experimental, and we can install it. So in this dialog, you find here install experimental plugin. The plugin was installed nicely, and now what you have is a new panel here. If you don't have it, again, right click, you can find it over here. So you have the mapping panel, you can open and close it, and you have also a toolbar, which is located here at this point, the mapping toolbar, okay? From the toolbar, you can also activate the panel if you want to, if you don't need it, for example. Okay, I believe I can show you very quickly again how to install it. So in the menu, plugins, manage and install plugins. Go under settings, remember to enable the show also experimental plugins. Now reload the repository, so it will list again all the plugins. Then now under all, you can search for mapping, and by selecting it, you can install it right here. So if you haven't done, if you started from an empty profile with the QGIS, you need to install it. And that's all. The last point I want to show you before giving the word to Riccardo is how we will be working to generate the polygons, the map. You see we have the mapping panel here. You have several input selection you have to do. Be sure to review everything before to go ahead and generate your map. So for example, we have a layer that will be the one with the contacts that we need to set to be the source contacts. The indicator points layer is the one that should be already set, because it's the only layer, point layer that we have in the project. Should be already set to be source indicators, and the unit fields should be set to be unit name. And that's basically all. We can choose where to output our data set. I will just leave it there. That's not really important at this moment. There are several options that are not important now. I just want you to try it out. So set the source contacts and source indicators in the input options here, and be sure that you have selected unit name as a unit field. When you are happy, in the mapping toolbar you can find this button that is called Recompute Map, and will recompute the map for you. So I'm just pressing it, and you see the first time it will generate a polygon layer generated starting from the contacts, right? You see the colors are all the same, and in a moment I will show you why. Because in source indicators, we have those points that will be used to provide the information about the geological unit we are mapping. And I show you how to modify it to create a better map. We select source indicators at this point. You see I disable some layers. I'm not interested in linear features, of course, and for the moment I'm not interested in the final contacts and in the source contact. I'm not really interested in those at the moment. Mappy created for you some points, 1, 2, 3, 4 points, right, in the source indicators layer. We will be using those to provide the labels for each of those units. To do so, we will need to enable editing for the point layer. So we select the source indicators layers in the layers panel. Then in the toolbar, in the digitizing toolbar, we toggle the editing. Now we should be able to edit each point. This means we can also move them around, etc. But for the moment, I'm interested in changing the label for each of those points. So to do so, I will be using, there are several ways to do this thing, but if you use identify features, should be easy. I press identify features in this toolbar, which is the the attributes toolbar. With identify features, I can now press on the canvas, on the point, you see the points get selected. And in this little panel over there, I will move it here on top, so it's easier. We'll just remove the mapping dialog. So you see, I've been selected a point. It gives me some information on that point, on the coordinates of the point. And you see, we have a unit name which is set to null at the moment. We need to provide a name for that point. If you click on Edit Future Form here on top, again, we select a point. We got some information on that point, the information connected with that specific point, and we can edit the point by using the Edit Future dialog. You see, it opens up this dialog, and you can actually now specify the unit name. So I will call unit A, and you see now it got updated with unit name A. A quick if you want to be quicker with that, you can in identify settings, you can enable that an option that is called auto open for single future result. If you enable that, every time you go over one point, you will be presented with this dialog. So let's say this is a different unit. This is unit C, and this is unit D. Here we are. So we modified, just do it once. You see now that this unit has a unit name, that is C. This unit has a different name, that is B, and this unit is A. Okay, when we are happy with it, we can just recompute the map. To do so, we go on the mapping toolbar, we press recompute map. It will warn us that we have saves that were not changed, so we can just press save. And you will see what happens. So we end up with new polygons. So we have our final map, where each polygon were correctly classified. So we have polygon A, B, C, etc. Okay, so the colors were attributed, let's say, automatically. You will see how to change those by going into properties, symbology, but it's not really important at this moment. What I want you to try out is to draw some lines, see how it works, and be sure to be able to add some indicator points the right way. And that's basically all. One layer that is also generated is called final contacts. And you see it's basically just the contacts you're tracing, but we removed let's say, those little lines that go over that are not really needed to define the polygon. So it provides you a very clean data set you can use to print your map later. I believe, Riccardo, it's